So this is the beginning of Chapter 8. Before you, you have a model of how gases move. Notice that the gas fills the container, but that the volume of the gas is quite small, so there's a lot of empty space in that container. The molecules are not sticky. When they run into each other, they bounce off. There's very little attraction between the molecules. And they are in constant motion. It's moving all the time. So let's write these down. We're summarizing the 4 points of the kinetic molecular theory of gases. Particles are in constant random motion. They move at high speeds in straight lines and random directions. There's little or no attractive force between the molecules. The molecules are far apart and they fill the container. The total volume of the gas particles is negligible. Most of the container is empty, so gases are compressible. And lastly, one that we didn't prove but didn't see, the average kinetic energy of the gas molecules, which is how fast they are moving, is proportional to the temperature in Kelvin. And we will be looking at this. We will see that if you increase the temperature, you will increase the movement of the molecules. So gases have 4 properties that we will be looking at. The first is pressure. The symbol for pressure, I've got to start. Symbol for pressure is P. The units for pressure are atmospheres, we will commonly use, millimeters of mercury, which harkens back to using a barometer, torr, pascals, PA, and the English system uses PSI. So if you look at your tires in your car, they measure pressure as PSI. Pressure is caused by the molecules hitting the sides of the container. So it's caused by particles hitting the sides of the container. I don't know if I'm going to have room or not. Okay. We will abbreviate container, make it all fit. Okay, the second property we'll be looking at is volume. Volume is measured in, usually we'll be using liters. Occasionally we'll use milliliters. Of course, you can measure volume in quarts and gallons. This is the space occupied. Temperature symbol is T, and we will mainly be using Kelvin. Occasionally we'll use Celsius. This is the measure of the kinetic energy or the motion. So at high temperatures we have fast motion. Low temperatures we have lower motion. The fourth property that we'll be measuring is N, which is the number of particles, and we will be measuring these in moles. Remember that moles is just a number. We might buy eggs by the dozen. We buy molecules by the mole. And this is just the amount present. So let's start with this conversion. Let's look. 1 atmosphere is 760 millimeters of mercury, or 760 torr. So what is 475 millimeters of mercury expressed as atmospheres. Well, this is just a conversion. We've been doing conversions all term. So we've got 475 millimeters of mercury, and we'd like to convert it into an unknown number of atmospheres. We have an equality right up here that we'll be able to use. We know that 1 atmosphere is equal to 760 millimeters of mercury. So using this equality, we can write two conversions. We can write that 1 atmosphere, oh goodness, I didn't know I was going to do that, over 760 millimeters of mercury, or we can do 760 millimeters of mercury over 1 atmosphere. So let's write our problem. Let's go back to boring black. 475 millimeters of mercury. And we're going to write our conversion. We need to pick the conversion statement that's going to get rid of millimeters of mercury. Put millimeters of mercury on the bottom and the unit that we want on top. So we're going to use this conversion. So we've got 1 atmosphere over 760 millimeters of mercury. Okay, so we'll take 475, multiply by 1, and divide by 760, and the number comes out 0.625. The units that are left, well, millimeters of mercury cancels out because we've got it in the top and in the bottom, and we're left with only atmospheres. So let's move up. The pressure in a tire is 2 atmospheres. So we're starting with 2 atmospheres. Starting with 2 atmospheres. And we'd like to know how many millimeters of mercury. Well, our equality is going to be the same. It's, I can get rid of that. It's right up here. 1 atmosphere. Let me see if should we use the pretty colors again? 1 atmosphere is equal to 760 millimeters of mercury. So we can write our problem now. We've got 2 atmospheres. We'll want to use our equality here to write a conversion statement. Atmospheres we're going to want to put in the bottom, and the millimeters of mercury we'll want to put in the top, so the units will work for us. So let's put our 1 atmosphere in the bottom and our 760 millimeters of mercury in the top. So we'll say 2 times 760 and divide by 1. We'll get 1,520. And the only units that are going to be left are going to be millimeters of mercury.